Hi, folks. This is the first installment now that I've reactivated my blog of climate change updates. So it is December 19th, 2022. So let me share my screen and we will begin. So I'd like to spend some time talking about where CO2 is every time that I do an update for the students. And you can see the CO2 in the air today is 418 parts per million. That's as of the last reading from Mauna Loa, the Keeling laboratory, before the lava flow knocked out the power on November 29th, 2022. And as you can see, CO2 is now on the rise again because in the Northern Hemisphere, we're burning fossil fuels to stay warm, and there's no photosynthesis, or much less photosynthesis, I should say, going on. And so we see this annual cycle. The prediction is that the overall concentration of CO2 in the air in terms of its mole fraction in parts per million will be higher next year than it was this year. It did reach above 420 parts per million. The last time the planet Earth had 420 parts per million CO2 was during the Pliocene over 3 million years ago. And so it's likely that we're going to exceed 420 parts per million again, and probably by a larger measure than we did back at the end of the non-photosynthesis season and early spring, essentially, when there's still a lot of CO2 in the air from industrial processes that has not been extracted through photosynthesis. So the good news from the International Energy Agency is that renewables will transform the global power mix through 2027, becoming the largest source of electricity. This is astonishingly good news. You can see that solar photovoltaic will exceed coal and fossil gas. Of course, the term that most publications use for fossil gas is natural gas. I choose to remind people that it's a fossil fuel. And you can see that bioenergy is a relatively small amount of the mix, and wind power is coming on strong. And so this is their latest report, which happened just a few weeks ago, I think 2 weeks ago. Global electricity generation by technology shown in this graph for 2015, 2021, and 2027. Oil, nuclear, natural gas, renewables, and coal as a percent. And you can see that the renewables is taking up a larger and larger portion of that generation. And that's really good news. And the only way that can happen is if the grid is also being transformed and there's increasing investment in energy storage. And that is in fact what we see. Fortunately, natural gas is becoming a smaller portion of the pie, and coal is also shrinking in terms by 2027, in terms of what is expected, or the projections from the IEA on its latest report. China will surpass renewable targets that it set itself through deployed wind and photovoltaic. So you can see the surge in the expected production of solar residential and solar utility grade photovoltaic, wind, a lot of offshore and onshore wind. This is the primary statistical projection, but in an accelerated case, which seems to be likely, this is what China will be able to do by 2027, and essentially in the next 5 years. Renewables of shares of renewables and electricity generation. Overall in China, the percent will be considerably above 40%, approaching 45%. And the percent of wind and solar PV will be almost 20%. This is far greater than what the United States is currently able to achieve or is projected to achieve. The United States renewable capacity additions and capacity growth, we see a similar trend. Photovoltaic utility and photovoltaic rooftop distributed all going up. The accelerated case is in the black diamonds in terms of gigawatts. In terms of overall percent, we're still below 20%, considerably behind China. Often when I present a public talk, the question I'll get is, well, what about China? And my response is, yeah, what about China? China has produced more solar and wind power than the entire European Union combined in the last year, and considerably more than the United States. The United States is, however, slated to come on strong with the Inflation Reduction Act. Perhaps some of the best news in terms of the marketplace for energy is the levelized cost of energy comparison. This comes from Lazard. This is, if we look at wind and solar, they've just fallen like a stone. They're considerably cheaper than natural gas. And this is cradle to grave, lifetime use of a resource through a facility. Coal and gas peaker and nuclear are both way up there. So the bottom line is the cheapest energy out there is wind and solar. And I noticed a lot of pushback on this graph on Twitter. And frankly, it's a bunch of people that don't know what they're talking about. The Lazard Group and the IEA gets the same result, by the way. You've got to be kidding me if you don't think that they've thought of all of the issues related to renewables, intermittency, all of these other things that drive the overall cradle to grave cost of energy over the lifetime of use. And so wind and solar, I think you can really trust that the levelized cost is the lowest for wind and solar. This is terrific news. It just keeps getting better and better in that regard. Electric vehicles are taking off. Bloomberg sees electric vehicles taking more share of the US passenger vehicle sales. This is the earlier forecast, and then the black line is what we expect based on the Inflation Reduction Act. That's really good news, but I would remind everybody that the IRA is in fact all carrot and no stick. We don't have any regulatory capacity with the IRA. What we have are incentives and marketplace disincentives. The plug-in share of total passenger vehicle shares in China is up to 26% in the first quarter of 2022. And that is astonishing. And you can see by 2025, we will still have not reached that level. So China, again, is showing the world how it can be done. And there's an enormous push in China to electrify essentially everything. The bad news is that CO2 emissions are higher than ever. And this comes from the Global Carbon Project. These are their latest data. And you can see that the projection for 2022, by the end of this year, we should be at about 37.5 gigatons of CO2 emissions for the year. And this is really bad news in the sense that with the COVID pandemic, we saw a decrease. And the initial projections were that we would level out or not increase that much relative to 2019. The projection is for 1% higher than in 2021. This is definitely not a good thing. And also coal is on the rise again. Oil, a little bit lower than it was in 2021 and or 2019. Gas and cement, you can see where they are. So the share of global fossil CO2 emissions in 2021, coal is 40%, oil is 32%, gas 21%, and cement 5%. The emissions are higher than ever, and what this shows as the weekly atmospheric CO2 concentration at the Mauna Loa Keeling Laboratory on Hawaii is the atmospheric CO2 concentration has increased every single year. And you read this graph from bottom to top, from 2012 up to 2022, because of continued emissions, despite the drop in fossil CO2 emissions. And so the weekly CO2 at Mauna Loa is higher than ever at the end of October. And of course, we will overall exceed 420 parts per million when it finally peaks out. The thing that drives radiative forcing is not the rate of emissions. Your rate can be increasing or decreasing, but what drives radiative forcing is what's in the air. And so the USA and the European Union have the highest accumulated fossil CO2 emissions since 1850, but China is not far behind. You can see the UK, which used to be included in the EU, is down here in number 5 position. So the historical cumulative emissions since 1850, this shows in the red 2022 projected, and this is really bad. So again, the last time we had more than 422 parts per million, 420 parts per million in the air was in the Pliocene over 3 million years ago. The graph is showing gigatons of CO2 in the air and the historical cumulative amount attributed to each of these countries. The per capita historical cumulative emissions are also worthy of note. And this comes from Hansen's et al. Latest paper, that's Jim Hansen of climate change fame. This paper is not peer reviewed, and we'll talk more about it in a minute, but these data are something you can take to the bank. They have been peer reviewed. So 1751 through 2020 cumulative emissions in terms of tons of carbon per person. Again, the US tops the league. The UK comes in second, Germany third, and the global mean is way down here in the dashed line. I would submit to you that the United States has a moral obligation to lead on climate change and not to block the kind of changes that need to be made. And we have a moral obligation, I think, to kill fossil fuels. So the national responsibility for ecological breakdown is even more telling. This is a calculation of excess material use from population-based quantification of fair share of total material resources available. And you can see the US and the EU plus the UK are responsible for most of the excess material use. High-income nations are responsible for 74% of global excess material use, driven primarily by the US at 27% and the EU 28%, including the UK at 25%. Excess material use is the most immediate cause of habitat destruction, extinctions, and climate change. There's a coming bottleneck that I think needs to be pointed out. We have an enormous number of transformations that have to be made sometime around mid-century. I think that similar to what Greta Thunberg has argued is that we're in mitigation denial. We simply don't comprehend the immense scale of required emissions reductions needed to keep us on track for a livable planet. Adaptation is not the answer overall, because it becomes harder and harder the longer extreme mitigation is delayed. And the most important point here is there are no non-radical or incremental solutions remaining if we are to avoid large overshoot of 1.5 degrees C and global tipping points that are projected to happen somewhere between 1.5 and 2. The required transformations by mid-century are mind-boggling, but I actually think we can do this if we put our minds to it and we collectively act as a species rather than as a group of combative tribes, shall we say. Adaptation to heat. The equator, regions in the equator are going to become to varying degrees unlivable as heat becomes more and more of a problem, especially in high humidity areas. Adaptations to drought and flood. We know both are going to increase. They have increased. There's been enormous damage. Look at the flooding in Pakistan. Look at the drought and extreme heat that happened in China during the latter part of the summer. Agriculture and food security are a major challenge. We're not increasing our rate of yield. Our increase in the yield of primary food commodities nearly as fast as we need to. We're going to start having considerable interest in transformation into alternative food supply. And the most important thing we've got to do is kill meat, especially beef. There's an enormous standing crop of cattle that essentially is responsible for most of the deforestation that's happening in the Amazon basin. Ecosystem restoration is urgent. We have degraded ecosystems all over the world, and the models that are used to measure the rate at which climate change is progressing are in large measure dependent on two things, both economics and human economics and the flux of greenhouse gases to and from ecosystems. Without going into the problems with economics, I'll say that we do a terrible job of measuring what the ecosystems are doing at this point in time, but we do know that we have large portions of the natural planet and semi-natural planet that have been severely damaged and need to be restored. Halting biodiversity loss. Some significant progress was made in the wee hours of this morning on the 19th of December at the Biodiversity Conference in Montreal, and we'll talk about that. Killing fossil fuels and deployment of renewables. Of course, the renewables are going to be deployed. They need to be deployed faster, but the real challenge here is we have got to disenfranchise the fossil fuel entities, and we've got to kill these emissions. Urban expansion and issues with land tenure. Informal settlements are going to boom. They're going to expand tremendously. And we need to address this issue. There are a number of ways to do it, but sustainable management of urban populations is going to be a real challenge. We have barely scratched the surface on that. And human migration pressures are going to become extreme. This book by Gaia Vance is really worth reading. She is a little bit wrong on some of her science, in my opinion. And she's very optimistic that we'll be able to make all of these transformations and that we'll simply move into northern climes. Well, okay. I think there's going to be some blood on the sidewalk, both literally and metaphorically, before we can get there. I do think she's right that if we don't if we don't avoid a large overshoot of 1.5 degrees C, that there will be significant migration into northern regions and the North Temperate Zone. The problem with her hypothesis is that we need to get through all of these challenges in order to make this migration possible. And of course, there are the political hurdles that center on migration. She points out correctly, I think, that migrants add to the political economy and the vibrancy of countries, and that borders should be mostly open. And I certainly agree with her. But she talks about urban expansion and how entire new cities will need to be built in northern latitudes. This takes time. It takes resources, and until we get off of fossil fuels, there will be an immense carbon debt associated with that. So her vision for what migration will, how migration will reshape our world, although probably correct in overview, is, I think, lacking in the kind of details that we need to consider this bottleneck. But I encourage folks to take a look at this book. I want to remind people that really the way the climate changes and the way ecosystem changes occur is through press and pulse. So press is the long-term average change, and the pulse are the short-term extreme events. It's those extreme events that are getting our attention, extreme marine heat waves that are doing enormous damage to the world's corals. And there's a mortality threshold shown in this cartoon. And indeed, that's what we see for a lot of ecosystems as they transform. Hansen and colleagues just published a newspaper entitled "The Warming in the Pipeline." This paper is very problematic. I am not convinced, but basically what he says is that aerosol cooling has been shielding us from experiencing the full weight of greenhouse gas warming. And the science behind that is correct. The aerosol warming cooling has been what he calls a Faustian bargain. There's some truth to that. However, the question is if we drove greenhouse gases to net zero, say by 2050, what would happen to the temperature? In Hansen's argument, he says the delayed response of climate to cumulative emissions has not been fully appreciated, and that equilibrium climate sensitivity for a doubling of CO2 relative to pre-industrial is about 4 degrees C, with a likely range of 3.5 to 5.5. This is distinctly different from the canonical or accepted version of ECS, which is around 3 to 3.2 degrees C. And so he thinks we're in for a world of hurt. Eventual climate, I think we are too, but maybe not for the reason he thinks. Eventual global warming due to today's greenhouse gas forcing alone, he argues, after slow feedbacks to the Earth system operate, which will take a considerable number of decades and possibly a couple of centuries, is about 10 degrees Celsius, maybe more than a couple of centuries. This analysis, he says, results from new glacial to interglacial temperature estimates, especially during the Eemian, which is the previous interglacial before the one we're currently in, and evidence that warming has progressively outpaced aerosol cooling since 1970. If Hansen and colleagues are right, warming in the decades following 2010 could be 50 to 100 times greater than in the prior 40 years. This paper has not been peer-reviewed, and key scientists like Michael Mann and several others have come out strongly stating that it is not correct and that it ignores, I think in Mann's words, the last 20 years of peer-reviewed science. And if we look at the IPCC special report 1.15, or that asks the question, is it possible for us to stay below 1.5 degrees C? This analysis shows that warming will quickly cease after zero emissions have been reached. The real question is whether or not it will be fast or slow, and how much overshoot will occur. The oceans would continue to remove CO2 after emissions cease, and this would nullify much of the argument of Hansen et al. Essentially, there will be overshoot in terms of 1.5, and that will cause immense damage due to hysteresis in living systems. The overshoot will be most important issue as far as I'm concerned, although overshoot might last only a few decades. The damage to ecosystems would be extreme. So the working group 3 for the AR6 had a lot of social science in it. So it's worth reiterating some of those important points. The interactions among politics, economics, and power relationships are responsible for the lack of urgent action. Corporations are primary obstructionists to climate action. The wealthy top 10% of individuals globally are responsible for 36 to 45% of global greenhouse gas emissions. The G20, i.e. the global north, is responsible for 80% of historical emissions, and the G77, roughly the global south, has contributed little to radiative forcing. Incremental change is clearly unacceptable. Only wholesale societal transformation will salvage a livable planet. Although technically agnostic about neoliberal economics, the report explicitly suggests degrowth economics as an alternative. If we look at the carbon bombs that are planned or in progress from the fossil fuel interests, they will take us far beyond the acceptable 1.5 budget. You can see what's producing now is already in excess of that, and what's planned will take us way beyond those numbers. This is extremely concerning, of course. So it's really important to look at the cascading and compounding impacts: global warming's impact on sea level rise, extreme weather, economic inequality, vector-borne disease, resulting in displacement, international and local conflict, mortality, change impacts on biodiversity, state fragility, ecosystem services, and ultimately food, fuel, and water shortages or resource scarcity. So I think it's appropriate to talk about integrated catastrophic assessments worldwide. The prudent risk management requires consideration of bad to worst case scenarios, yet for climate change, such futures are poorly understood. Although present projections indicate that our current trajectory will warm the Earth possibly less than 3 degrees C, and with globally coordinated strenuous efforts at emissions mitigation, we can stay below 2. The models used for these projections are integrated assessment models with flawed assumptions about the global economy, including inaccurate reporting on emissions by nations and fossil fuel companies. The models poorly estimate ecosystem and agricultural carbon flux, as I mentioned earlier. There is ample reason to suspect that climate change could result in a global catastrophe, especially given the bottlenecks that we must move through, the transformations that must happen for us to maintain a livable planet. Finally, I want to talk about a couple of new results. And the first of these is the fanfare around fusion as a carbon-free source of energy. There has been a breakthrough in terms of sustained fusion power. And there was a glowing announcement by the US Department of Energy. Nevertheless, this breakthrough was never about producing energy to power civilization. Instead, this program was run by a research group funded to demonstrate at one of the national laboratories that sustained fusion would reflect the ability to validate the reliability of the US nuclear arms arsenal without actual testing of the bombs. So this is really a signal to the nuclear arms fraternity, if you would, that we know we can blow these bombs up, that our bombs will work, because the things that are necessary to get this sustained fusion reaction that generates more energy is essentially a very well-controlled hydrogen bomb. And the mathematics involved is what's necessary to validate the reliability of the US nuclear arsenal. This is reported by the Bulletin of the Atomic Scientists on the 16th of December of 2022. Any application of this result for emissions-free energy is several decades into the future. This design is very expensive and is poorly suited to such an application. It cannot be scaled up. from everything that I've read. Nevertheless, this does constitute a major scientific achievement. COP15 for the Convention on Biological Diversity has resulted in a historic agreement that happened in the wee hours of this morning on 19 December. Here are some of the main points. 30 by 30. They agreed to conserve 30% of the Earth by 2030 and maintain, enhance, and restore ecosystems, hallelujah, including halting species extinction and maintaining genetic diversity. Sustainable use of biodiversity, essentially ensuring that species and habitats can provide the services they provide for humanity, such as food and clean water. Payment for benefits of nature. This is ensuring that the benefits of resources from nature, like medicines that come from plants, are shared fairly and equally, and that indigenous people's rights are protected. This includes payment for and rights to digital genetic information derived from the genomes of species. And finally, reform of environmentally harmful subsidies and disclosure of extraction by businesses. So paying for and putting resources into biodiversity, ensuring that money and conservation efforts get where they are needed. So thank you again for your attention. And as I said, I'll be continuing with this work at least once a month. I'll post an update for the students in my classes and also for the general public. Bye-bye, folks.